So the first thing here is a scalar multiple. So we're just going to multiply the components by the constant term that they put in front. We can also add and subtract. When you add and subtract, you combine the x components and you combine the y components as well. So with the vector v being negative 2, 5, and the vector w being 3, 4, let's do these vector operations right here. So the first one is 2 times v. That is a scalar multiple. So we're going to take the v vector there. Let's just plug in its components, and then we multiply. It's kind of just like distributing. Okay, you just multiply the x by 2, you multiply the y by 2, and that's what you've got. If we kind of illustrate this to ourselves, see if I can somewhat make a to scale graph here. We start with, well, it might help if I went in the right x direction there. It would be negative x, positive y. So negative 2, positive 5, this is what our original vector looks like. And then we go to negative 4, 10. Yeah. Okay, so negative 4, 10. All we've done here is extend our vector. Okay, it doesn't move, it doesn't change where it's at. It is just lengthened it by a factor of 2, is what scalar multiplication does. All right, let's look at the second one, b, w minus v. So w minus v, w was the vector 3, 4, minus the vector negative 2, 5. Whatever is in between here is what you do. So you do that with the x's, so 3 minus negative 2, 4 minus 5. So we end up with 3 plus 2, so that's 5. 4 minus 5 is negative 1. Okay, then v plus 2w. So we've got our vector v plus 2 times w. So of course we need to multiply by that scalar first. So that's plus 6, 8. And then we can add the x's, add the y's, and we're finished. 413 is the answer. Now, there is an algebraic way, or excuse me, a geometric way to look at this as well. What you do when you add vectors is you essentially, they call it tip to tail. Okay, so if we start with, this one says v, we start with v first, so we graph our negative 2, positive 5. So that's our v vector. And then 2 times w was 6, 8. So you start where you're at negative 2, 5, and you're going to go, 6 is positive, so we go right 6 units from there. So we're going to end up at 4. And then we go up 8 units. So we're going to end up, so that's our 2w right there. And so 413 is the resulting from where you started to where you ended. When you put the vector tip to tail, the first one to the second one, this is the resulting, this is what v plus 2w is over here. Okay, it kind of completes the triangle, so to speak, from the origin to the tip of where it ended. Let me do that one in a different color. Okay, so that's just the geometric representation. Do I think you really need to worry about that? No, but I wanted to show you. I did want to show you. All right, let's do one more. Let U be 1, 4 and V be 3, 2. So if we add those together, we are just adding the x's, the x components, adding the y components. Obviously, you should get to the point where you don't really need to show the work, but I want you to have something to look back at. So 4, 6 is the resultant vector when you add 1, 4 to 3, 2. Okay, 2 times u minus 3 times v. Apply the scalar multiple first to 8. Just like with regular numbers, go ahead and treat that as a -3. So -9, -6, and it turns into addition if you distribute the -3. If you just distribute the +3, then it's like subtraction. I would rather distribute the negative number and add than just distribute the number and have to subtract. Either way, you should get -7, +2. All right, one more. -v plus 4u. Put a negative in front of the v vector. Plus 4 times our u vector. So distribute that negative in there. -3, -2, plus 4, 16. So we've got -3 plus 4, -2 plus 16. +1, +14. Any questions?